Hello everyone, this is Casey, and today I am going to show you how to generate code in multiple object-oriented languages that make accessing relational databases very easy. Before delving into a demo, I'd like to talk about a few conceptual points. Most computer programs access a relational database to store or look up data. Although high-level libraries make programming jobs very easy, creating classes that represent tables in a database is often very tedious and repetitive work. Consider a table with 50 columns, and you need to create a class that represents this table in an object-oriented language, like Java or C#. It's very important not to mix code belonging to a business logic with the view. Even within the business logic, it is better to keep the code that accesses databases separate. It's very common for the back-end design to change, and you don't want to make lots of changes in your business logic to accommodate for this update. For example, if you add a new column in a table, your existing code should not break, or if it breaks, you should get a compile time error so it can be fixed easily. There are two ways to accomplish this task. First is the object relational mapping, which is typically provided by libraries. Programmers use these libraries that automatically create objects representing rows in a table. The second method is to manually create classes that represent the relational structure exposed by a table. We will talk about this second method in this video, but show you how to create this code so you don't have to do it manually. Let's talk about automatic OR mapping and see its pros and cons. As far as advantages go, they provide a dynamic mechanism to automatically define objects representing tables and also provide an abstract method of creating objects. Most ORM libraries create SQL queries behind the scenes, allowing users to focus on business logic rather than data access logic. Depending upon the library used, your code can stay shielded from the database vendor. For example, if you later switch from, let's say, Oracle to DB2, the only thing you may have to change is the connection string. Now, let's talk about some disadvantages. Some of the advantages mentioned earlier could actually become a disadvantage in certain cases. Since ORM libraries hide actual SQL statements, programmers have less control over the queries. For example, you could rewrite a select statement by using particular index hint if you know that will return results faster. Similarly, if our ORM library is specific to a certain database, you will have a tough time switching to a different backend. Some ORM libraries have restrictive licenses preventing you from deploying royalty-free applications. Most ORM libraries have a learning curve. Often programmers are tempted to quickly write code by looking at a few examples without realizing the scalability requirements down the road. Therefore, it's important to fully understand the library before using them, and that can take some time. You'll have to package the library along with your code when deployed. This may increase the total size of your deliverables. Many ORM libraries use reflection heavily in order to create and modify the state of objects. This performance penalty gets worse in a highly transactional environment. Static code, on the other hand, doesn't have any of the disadvantages mentioned in the last slide. The biggest disadvantage of static code is the time it takes to create manually. The code itself is repetitive and tedious. In a few minutes, I will show you how to generate the static code using WinSQL with just a mouse click. However, let's go through the design of the code before we do that. Assume you have a customer table in a database. The goal is to create classes that not only represent a single row, but a collection of rows from this table based on a query. Take a look at the following class diagram. Altogether, there are 5 classes. The first class is a value object. In this case, it's called a VO customer. This class contains a variable for every field in the database, along with their getters and setters. There is nothing related to the database in this class, and therefore, objects of this class can be used to exchange data between multiple systems or tiers. Objects of this class represent a single row in the customer table. The second class is a data access object. It is called a DAO customer in this example and is inherited from the value object. This class is the one containing all the CRUD operations, such as insert, update, and delete. It also contains a method called fetchByPK, which fetches a single row from the database based on a primary key. The next class is DAO customer collection, which represents a collection of DAO customer. This class serves as an in-memory cursor. It contains a fetch_all method that issues a select statement against the database and holds the results of that statement in memory. Once the object is inflated with data, you can move up and down the cursor using methods like next, previous, first, and last. Finally, there are 2 classes which are an extended version of DAO customer and DAO customer collection. These are empty classes, and you should use these to instantiate objects in your code. The objective here is that you never modify either the value object or the two data access object classes manually. Any modification containing additional logic must be made to the extended versions. This way, if your database design changes, you use the tool to recreate the value object and data access object classes, but not the extended versions. So now, let's see how this is done using WinSQL. First, I am going to connect to my desired database. Navigate to the table I need to generate code. Right-click and select Generate Code for Data Access Objects from the pop-up menu. On the following screen, I specify some important parameters such as output directory, company name, and header comments. I select the desired code template from here. Notice there are different languages and also the access mechanism. For example, when generating code for C#, I can select if I am connecting to SQL Server or some other backend that supports either OLDB or ODBC. Additionally, I can also select if I only want to generate code for just value object or both value and data access object. For this example, I'm going to select PHP for my language. Notice that the namespace convention used in PHP contains slashes rather than dots. Therefore, it gets modified for you. If I would have picked Java for my language, this field would have said package instead of namespace. The grid at the bottom allows me to modify some of the prefix and suffix in the class names. I'm going to leave them as default for the time being. Finally, I click Generate Code. Once done, WinSQL will open the folder containing generated files. Now, if you want to generate code for multiple tables, simply go to the main menu and select Data Access Objects from here. I then have the option of selecting one or more tables from the list. I can now open any file and browse through the code. Notice that the code is nicely commented with protected access to most functions, allowing the extended version of the class to override them if necessary. Now let's look at a code snippet in C# that uses the generated class. Notice that I am using the extended version of the customer class. I do that because any additional code related to the customer table will be in the extended version. The base classes will be recreated by WinSQL when the back-end design changes. In order to insert a new customer, I simply call the insert method. Note that I did not specify a customer ID. That is because the value of that field is automatically generated in the database. Once the insert query succeeds, I can fetch the newly inserted ID by simply calling the getter method. In the next example, I'm going to fetch a customer by providing the customer ID in the fetchByPK method, which returns a boolean. The if statement confirms I was able to successfully fetch. I then modify the customer's address and call the post method, which will eventually run an update query against the database. So, to summarize, I just showed you how to create static code containing hundreds of lines of code in multiple languages using WinSQL. Imagine if you have a table with hundreds of fields and had to create a value object representing the table's data in your code. WinSQL reduces that tedious task to just a few mouse clicks. I hope you enjoyed watching this video and recommend you watch other videos on our website. Thank you and have a nice day.